it is 9 o'clock, so we're gonna go ahead and get started. I hope you guys are doing well. Happy Tuesday to everyone. So thank you for the people who were able to get here early. Hopefully you guys had a chance to look at the warm-up. Attendance isn't looking super great. We should have 33 in here, but we only have a little time to get going. So I'm going to go ahead and get going. So hopefully if you got in here on time, you had a little bit of time to review what we did last class. Just a reminder, I have a lot of students in this class who are not turning in homework. Please make sure that you guys know your homework is 80% of your grade. If you guys aren't turning in homework, you're missing a big part of your grade. There is no penalty for turning in late work. But make sure you guys check Skyward. If you are turning in late work and I haven't updated Skyward, you should probably send me an email. It's because I don't get notified when you turn in late work. Okay? So make sure you guys are doing that. Today, if you look at the title of what we're talking about, we're going to do exactly what we did last class with angle rules, but today we're going to switch the hypothesis and the conclusion. So that's what we called, remember, the, I was going to say coronavirus, the converse. Okay, so we're going to be doing the converse of what we did last class. And so that's why I started with this warm-up. I started with this warm-up because what we're doing today builds off what we did last class. So we have to make sure we understand this. Okay, so that's what we're going to be doing today. So taking a look at this, what we're going to do here is I'm going to go ahead and find the measure of every angle. And I just went ahead and I just made up a bunch of numbers so that people aren't mistakenly identifying the number with instead of the angle rule. Okay. So what we're going to do is we're going to go ahead here and find all of these angles and justify why. Now remember, our answers should be the same, but our reasons might look different. There's more than one way of getting the right answer. Okay, so as I go through this, if you guys were like, well, I did something different, you can always just send me a private message and I can tell you whether or not that you're good to go. Okay, so remember guys, we're checking our work as we go, and if you guys have questions, you can either turn on your mic or you can send me a private chat. Okay, so in this problem right here, it says given the measure of angle 8 is 72 degrees. So that's this angle right here. So if this angle is 72 degrees, remember we talk about this as groups of angles as being like cities, right? So we have two cities. It's often easier to deal with inside your own city, right? That's linear pair and vertical angles, because then we don't need parallel lines. So if this angle right here is 72, I'm going to start out with the easy step and be like, hey, I have two lines crossing, right? So I have an X. So I know that I'm going to have vertical angles. So whatever angle 8 is, angle 10 has to be the same. So I know angle 10 has to be 72 degrees because of vertical angles. And again, you might have written down a different reason here, but at the end, you should get angle 10 is 72 degrees. Okay? So I got these two angles now. So the next thing I'm going to look at, well, hey, if I take a look at 7 and 8, they're on a line. They're adjacent on a line. This is going to be a linear pair. So that is, here I'm going to have some space to write an equation. Angle 7 plus 72 degrees is going to equal 180 degrees, right? Because I know this is going to be a linear pair, right? And the 72 degrees, that was angle 8. So to solve this, right, I subtract 72 from both sides. Okay. And I get angle 7 equals 108. Right, so here I can write that. Okay, 108. And then what's my reason? I did a linear pair. Sorry, I kind of ran out of room there, so I had to write a little bit smaller. Okay, so again, you guys could have used something different, right? You could have gone 8 and 11 first with a linear pair and then done vertical angles. So there's lots of different ways of doing this. Speaking of vertical angles, now that I know angle 7, aren't angle 7 and angle 11 vertical angles? So I know angle 7 and angle 11 are going to be the same angle. And I know that because of vertical angles. And again, I'm writing down my reasons, and the reasons are really important, but they might be different reasons than yours. Okay. So now, like, check this out. We've gotten all the angles in that left city, right? But now we're going to have to go in between cities, in between groups. So the first thing I'm going to check is, do I have parallel lines? And I do have parallel lines. So because I have parallel lines, then I know all of my parallel line rules are going to be able to give me values, right? And they're not just angle pairs, they're angle rules. So again, there's lots of different ways to do this. If I'm starting with angle 1, I can notice that angle 1 here is in the upper left of this right city. So what's on the upper left of this one? 7. So remember, corresponding means different cities, same location. So, and because they're parallel, I'm going to know angle 7 and angle 1 are the same angle. And I know that because if parallel lines, right? Do I have parallel lines? Heck yes, I do. Then corresponding angles are congruent, right? And that's what I'm saying. I'm saying angle 1 and angle 7 have the same value. Okay. And then what are we going to do next? So 3, right? So we could just do corresponding for all of these angles, right? Since we went ahead and got all of the angles in this first city, I could do corresponding for all of these. That's not very exciting. So let's switch things up a little bit. So if I want 6 down here, I notice that 6 is in the inside, right? So that means I can have alternate interior angles. So 8 and 6 are alternate interior angles. So that means 8, which is 72, is going to be the same as 6. And that's going to be because if parallel, then alternate interior angles are congruent. Okay, so this is going to be the same as 8, right? So I'm just trying to show you there's lots of different ways to get these things, right? And then now that I have 1 and 6, right, I can do 6 and 3 are vertical angles, right? 6 and 3 are vertical angles. So 6 and 3 are going to be the same. And I like writing vertical angles because it's a lot shorter, right, than writing the if-then statement. So that's kind of nice. And remember, linear pair and vertical angles don't require parallel lines, which is why we don't need to write the parallel lines things. And then 5 and 1 are vertical angles. So 1 is 108. So I can say, hey, this is 108 because I have vertical angles. Okay, so this was just a little practice of what we did last class. Does anybody have questions before I move on to the new stuff? Remember, what we're going to be doing today is we're going to be doing all of this backwards, right? We're going to be doing the converse, where we switch the conclusion and the hypothesis. So does anybody have questions this? Because today we're going to look at it a little bit differently. Okay. Yeah, good. And as you guys are responding, I have a lot more students here now. So please remember, I have a lot of students who don't have a lot of assignments turned in. So remember, assignments are 80% of your grade. The midterm was only worth 10%. If you guys are looking to get your grade up, the best way to do that is to turn in missing assignments. There's no penalty for late work. You just got to turn it in. You get graded on percent correct. So if you turn in an assignment and you don't like your score, email me with your name. Well, your name's in the email. Email me with the assignment and what period you're in, and I can unsubmit it and you can work on it again until you get the score that you want. And to do that, you guys can come see me in my office hours and we can do the work together. Okay? So everyone in here should be able to get a good grade if you're willing to sit with me and do your work with me. Okay? Like, everyone should be able to pass. We just got to do it, guys. So if you need help, please let me know. I want to help you. All right. Next up, what we're going to be learning today. So we're going to learn about the converse rules to prove lines are parallel. Right? So last class, remember, we were really focused on, are the lines parallel? And the lines were either parallel or not parallel, right? So that would be really nice in life if someone told us if they were parallel, because it would make solving things easier. But in real life, we often are using things to prove lines are parallel. So if I'm building something, I want to prove that what I'm building is square. I want to prove what I'm building right, is straight up and down. Okay, and that's really where this type of geometry is used quite a bit until you get into more abstract math concepts. So at a very entry level, this is where it's used the most. Okay, so a couple things to remember. A converse means to switch. Okay, so we're going to take the rules that we had before, and we're just going to switch the hypothesis with the conclusion. And by switching them, it gives a really different meaning to those rules. So before, it was like, hey, are these lines parallel? Then this is true, right? But now we're going to be concluding, hey, lines are parallel. Okay, so, and I want to apologize here. If we were in class and we had more time, more than 50 minutes, I would be able to prove to you all of these angle relationships and show you that it's not just me telling you these things, and that these things are just they're just true things of life. So I can't do that for you, and I'm really sorry. So what I'm going to do here is I'm going to list them, and I really apologize for that. And then we're just going to spend the rest of the time using them and seeing how to use them, and maybe doing a little bit more difficult problems so you guys feel a little bit more comfortable. Okay. So let's list them out. The converse angle rules. Okay, so I'm just going to have them in one place because remember, everything is open notes, so it's kind of nice to have everything in one place. So last class, we learned all of these angle rules. So all I'm going to do is we have 4 angle rules that require parallel lines, and I'm just going to write them as their converse. Okay, so the first one would be if corresponding angles are congruent, then parallel lines. Okay, so see how we took what we had yesterday and we just switched the hypothesis and the conclusion. So instead of starting with parallel lines, I'm ending with parallel lines. And that's really different. So before we were given parallel lines, we're like, okay, what happens? Now, if I can show corresponding angles are congruent, then the lines are in fact parallel. Okay? And this is going to be the same for all of them. So like I can say if, and then I have alternate interior angles are congruent, then parallel lines. Okay? So again, what we're going to see here is a pattern. We have an angle relationship being true, and we're concluding, okay, if this angle relationship is true, then the lines have to be parallel. Okay, and if you're building something, that's a great way of knowing that things are parallel. Okay, so if we have alternate interior, we're also going to have alternate exterior. Okay, and that's going to do the same thing. And then the last one is the only one that's going to be slightly different because consecutive interior angles aren't congruent. Okay, so again, these are what we learned last class, but now instead of being given parallel lines, we're going to prove the lines are parallel. Okay, so if, and then so this one is consecutive interior angles are supplementary, then parallel lines. So remember, this last one, you might want to put a little star with it. See how all of these are congruent? Consecutive interior angles are supplementary. And we'll take a look at that one today in class. Okay. So it's super important here, guys, that all of these, how are they different than what we did last time? All of these are concluding, or they conclude that we have parallel lines. Okay, so these all conclude that we have parallel lines. So the number one thing students make mistakes is that they'll have a proof and they'll be like, oh yeah, that's alternate exterior, but they write down the wrong rule. Okay, so these are different rules than what we did last class. The last class is you start out with parallel lines and these angle rules are true. Here we're saying if this angle rule is true, then the lines have to be parallel. Okay, so we only use this when we want to show parallel lines. Okay, so this is only when we want to prove parallel lines. And students struggle with that every year. They want to use both of them at any point. So you know this because look at the conclusion. The conclusion is parallel lines. You're only going to use this if you're stating lines are parallel. Okay? And we'll practice doing this, okay? All right. So we have all of these in one spot. I hope I'm giving you guys plenty of time to write this all down. I don't want to be rushing you. Okay, so now that we have these all down, I want to give you some examples of how we're going to be using these in your homework and how we're going to be using them, how you'd use them in life, and etc. Okay, so let's do our first example. Okay, so I'm going to draw two lines. I'm going to call this line M and this line N. And I'm going to draw a transversal. Okay. And then I'm going to add in some angles. So on the upper right, I'm going to put 3x plus 5, and I'm going to put parentheses around it and a degree symbol so we know we're talking about the angle, not the segment. And then down here, I'm going to put a 65 degrees. Okay, so this is our picture setup. And then the problem's going to say find the value of x that makes M parallel to N. Now remember how what this is saying is line M is parallel to line N. It's just shorthand. Okay, so we're going to find the value of x that makes these parallel. So, and I should have said this before I wrote that down, right? When again, what we've been really talking about here is these lines look like they're parallel, don't they? But we don't have anything saying that they are parallel. So all we know is that they could be parallel. So what we're going to do is we're going to use math to show, yeah, what's up? Good. I'm glad that you see it now. Good, good. All right. So we're going to find the value of x that makes these parallel. Okay. So to do that, we're going to have to do a little mini proof. Okay. So the first thing we have to do is we have to realize there's only 4 ways that we have to prove lines parallel. Okay. So right up here, there's only 4 ways to do that. So if we're going to prove these lines parallel, it has to be one of these, which means to get the lines parallel, we have to make one of these statements true. So all of these are different angle rules. So the first thing we're going to have to do is look at these 2 angles and say, hey, what angle rule are these 2 angles? And so in chat, can you guys tell me, what angle rule are these 2 angles? What type of angles are they? So from this list, right? From this list, what type of angles are these? Yeah, no need for the question mark there. Come on, guys. There's 33 students in this class. I should get more than a few responses. What type of angles? Whether you're right or wrong, I need to know if you guys understand this or if you don't understand this. So if no one responds, then I think everyone gets it, right? So again, you're looking at this list of 4. You have a 1 in 4 chance of just guessing. If you had no idea, you could just guess. There we go. Okay, I'm getting more people. Come on, guys. Keep coming. Okay. Now, remember, this is math. So there's got to be a reason for everything. So the way that I would go about this is if you look at, you guys see how these 2 say interior? Well, if I look where the inside is, right? Only one of these angles is on the inside. This other angle is on the outside. So it can't be alternate interior because they're not both on the inside. They can't be both consecutive interior because, again, they're not both on the inside. And it can't be alternate exterior because only one of them is on the outside. So if you're totally stuck, you can use the process of elimination to figure out which one we're using here, right? So they can't be alternate interior. They're not both on the inside. It can't be alternate exterior. They're not both on the outside. And it can't be consecutive interior because they're not both on the inside. So that leaves us with corresponding. So are they in the same location? This is in the upper right. This is in the upper right. They're going to be corresponding. Okay? So if we want these lines to be parallel, then we have to make them equal. We have to make them congruent. That is, right? I'm going to go 65 degrees equals 3x plus 5. Right? And I'm doing this because I'm following this. If corresponding angles are congruent, and maybe I'll write that down here, right? This is my goal. My goal is if corresponding angles are congruent, then parallel lines. Okay? So I'm going to make these congruent, right? I'm going to make this statement true so that this conclusion happens. So I'm going to go ahead and do some algebra, right? I'm going to subtract. So I get 60 degrees equals 3x, and then I divide by 3, and I get 20 equals x. Okay, so my conclusion then is if x equals 20, then m is parallel to n. Okay, and that's how I write my answer as a sentence. Okay, so this is a really basic entry-level practice problem with this. The idea being we want the lines to be parallel, so I try to find a pair of angles that form an angle relationship, and then I solve for x so that it's true that this statement is true. Okay, if they had done consecutive interior, right, then they would have added up to 180, right? So the equation depends on which one you pick. Okay, you can see 3 of them, you set them equal to each other, and 1 they add up to 180. Okay. Does anybody have questions about this so far? Any concerns? Okay, now, we don't have a lot of time, and we could spend time practicing these easy ones, but what I want to do is I want to expose you guys to a little bit more difficult problems, because the more exposure we have to more difficult problems, then these smaller ones are going to seem easier, and then you're going to be able to more likely do those more difficult ones. So I'm going to show you guys a couple of problems here that are proofs that are going to be a little bit more complicated than what you're going to see on your homework, in the hopes that it makes that you guys see the process and that it makes your homework easier. Okay? And we're going to do them together. So if you guys have questions or you get confused, then please ask and do this. And remember, when we're doing proofs, this is really different, right, than just doing algebra that you're used to. So if you guys get stuck or frustrated, that's normal because you're doing something new. So make sure if you need help that you email me or you come to my office hours and I'll help you out. Okay? I just had a student this morning who came in and they were really stuck on one question, and it took less than 5 minutes, and they were like, "Oh, I get it." Okay? All right. So we're going to do a proof together. Okay? So I'm going to call this section, we're going to prove. So we're going to be, we're proving lines parallel. And we're going to do that using hashtag problems. Okay? Because if we all do a hashtag problem, then it will be trending in this class. All right, so we're going to do hashtag problems because they're really a nice entry point into more complex problems, okay? So, again, you're going to be like, wait, like, when are we going to use hashtag problems? Well, hashtag problems actually show up quite a bit in city development. But, again, we're doing this so that you guys have a nice, easy entry into proofs. So to do this, we're going to set up a problem. We're going to start by drawing a nice big hashtag. Okay, so it's going to take 4 lines to draw a hashtag, like that. And remember, don't worry about your picture looking exactly like mine. It's just a hashtag. I'm going to go ahead and label some of these lines. So I'm going to call this line R, line S, line P, and line Q. And then to make things easier for you, the book and I are going to highlight some angles so you're not overwhelmed, right? Because if you take a look at this, how many cities are we going to have? 1, 2, 3, 4. And each one has 4. That's 4 times 4 different angles. That's 16 angles. Okay, so that's overwhelming. So the book and I are going to make this easier for you, and we're going to highlight some angles so that way you're not overwhelmed. Okay, so for example, I'm going to put a 1 down here. I'm going to put a 2 over here. And then I'm going to put a 3 up here. Okay, now this is going to be frustrating because it forces you to solve it one way, but it's really nice because you're not going to be overwhelmed with like there's so many different ways to solve this. Okay, so we're just going to focus on these 3 angles. All right, now with any problem, you're going to have a given. So let me write down my givens. So in this case, we're going to have 2 givens. So one is that R is parallel to S, and angle 1 is congruent to angle 3. So we have 2 givens. So R is parallel to S, line R is parallel to line S, and angle 1 is congruent to angle 3. And then what we're going to try to prove here, we're going to try to prove that line P is parallel to line Q. So again, notice what we're trying to prove here. We're trying to prove that the lines are parallel. So we're going to be using our new rules, right? So we have 4 new rules that show lines are parallel. So to do this, I'm going to use a 2-column format. Okay. So I'm going to have statements on the left, and I'm going to have reasons on the right. And I'm doing this so that I'm organized and it's easy to read and do. Okay. So in chat, can you guys tell me, what do we always start with proofs? We've talked about this before. What do we always begin with? What do we write down first? Baller status. I'm seeing nothing but ballers in chat. Okay, this is good. So you guys remember this, right? And so I appreciate everyone typing this in because this tells me you guys are okay with this part. Okay, so we can focus on the other parts. And you guys were absolutely right. We're going to start with the given. And I have 2 givens. So I'm going to write here, I got step 1. I have R is parallel with S. Okay, and that is given. And I'm going to write them out as 2 separate lines because our brain is going to see them as 2 separate things then, and it's easier for our brain to break it down. If you write them all in one line, sometimes it's harder for your brain to break them down. The book, you might see the book sometimes write them all in one line. I hate that it does that. Okay, 1 is congruent to angle 3, and the reason here is given. Okay, so I wrote down my givens, right? It's almost like we haven't even started this problem, right? We're still just copying down the problems. Okay, so I got my first 2 givens. Now, what I like to do after getting my givens, I'm a very visual learner, and so it's really important for me to be able to update my diagram with my givens, okay? So the first one I'm going to look at is R is parallel to S. Well, there's nothing on this picture to indicate they're parallel. So I'm going to go ahead and add in some arrows here so that when my brain is looking this, I know that those 2 lines are parallel. It's going to help out quite a bit. Okay, so that's the first one. I have R is parallel to S. And then I'm going to have angle 1 is congruent to angle 3. So I have angle 1 here is congruent to angle 3. And I want to warn you guys, right? As we're doing this, are you guys noticing how I'm talking about what I'm doing, right? I'm describing what I'm doing. proofs, remember, are not algebra, right? There isn't a formula that you're going to use every time. This is a process. It's a problem-solving process. So you guys need to really focus on what am I doing, how am I doing it, when do I do it, okay? All right, so all I did is I wrote down my givens, and then I showed what angles are congruent. All right, so my next step, right, is, okay, what the heck am I doing, right, with problem solving? Where am I trying to go, and how am I going to get there? Okay, where I'm trying to go is that P is parallel to Q. Well, I have this list of ways. To prove lines are parallel. So if I want, right, if I want to prove these lines are parallel, I have to use one of these, right? So do you guys see how this phase, after I write down my given, I'm planning, okay? So I want to prove lines parallel, so I have to look for these. I have to look for corresponding angles, or alternate interior, or alternate exterior, or consecutive interior, okay? So let's take a look at our picture. If I'm going to prove P is parallel to Q, I need to have one angle on P and one angle on Q. So let's look here. Well, if I look at line P, there is only one angle on P, right? And that's 3. You guys see that? So there's only one angle on line P. But on line Q, I have 2 angles. Now we have to be really careful here, right? Because not only do they have to be on this line, they have to be connected. You guys remember learning about connections. We're connecting cities. So can you guys look at angle 1? Is angle 1 connected to angle 3 directly? That is, from this city in the bottom right to this city in the upper left, is there a direct connection? Right? There isn't. If I'm in this city and I want to get to this city, I'm either going to have to go up and then left, or I'm going to have to go left and then up. You can think of this too as like a city block, right? If I'm here and my friend's house is here, to get to my friend's house, I'm going to have to go over a block then, right? I'm not going to drive through people's yards, right? As tempting as that is, right? So the problem here is, so there's 2 angles on Q, but one isn't connected to 3. So that leaves us with just 3 and 2. 3's on P, 2's on Q, and they're connected by a transversal. So can you guys help me in chat? What angle relationship is this? I already had one person tell me what this angle relationship is, but everybody else, what angle relationship is this? Right? And if you forgot, remember, you have a list, right? So there's this list. We're trying to figure out what angle relationship is it. Are they corresponding, alternate interior, alternate exterior, or consecutive interior? Dang, some of you guys are like super fast on the keyboard. I don't even know if I could type that fast. That's not true. I probably could. All right, so we have, right? So if we're taking a look at these two, they're definitely interior, right? So they're going to be alternate interior. So what I want to write down here, right? Because as we're doing this proof, I'm just going to make a little note, right? If alternate interior angles are congruent, oops, I'm just making a note over here, then parallel lines. And the reason why I'm writing this note down is, if we can show 3 and 2 are congruent, don't these lines have to be parallel? Right? So we have alternate interior angles on P and Q, and if these are congruent, then these lines have to be parallel. So this is what I'm going to try to prove. Okay, that's my goal. If I can show that these 2 angles are congruent, then I know I'm going to have parallel lines. Now I'm going to stop there because that's really the most important part about proofs. After you get the givens down, you have to make a goal. Okay, what am I trying to accomplish? Are you guys okay with this? Does anybody have questions, right? So all I did is there's only 4 ways to prove lines parallel. So I looked for one of those relationships, right? And it looks like the only one that we can possibly do here is 2 and 3. And that's where it helps just focusing on 3 angles, right? So instead of having a whole bunch of options, there's only one option. And that is, we're going to have to show that 2 and 3 are congruent. Are you guys okay with that? Do you have any questions? I understand this is complicated, and it's new. Thank you for sharing. I appreciate that. All right, so now that we have a goal, we're going to go ahead and finish up this proof. Okay, so what I'm going to do here is next, let's take a look at what we have. I have 1 is congruent to 3. Well, that's halfway what I want, right? If I want the angles to be congruent, but what angles do I want to be congruent? 2 and 3, right? I want angle 2 congruent to angle 3. That's my goal. Well, we're halfway there, right? I have angle 3 here, okay? And that's good, but I don't want angle 1. We want to be able to replace angle 1 with angle 2. Does that make sense? Are you guys with me on that? So I want angle 2 congruent to angle 3. I have an angle 3 congruent to something, but I don't want the angle 1. So my next step is I'm going to have to figure out a way to show angle 1 and angle 2 being the same. So I look up here and I'm like, well, take a look. Angle 1 is on line S, and angle 2 is on line S. In chat, can you guys tell me, is this an angle relationship? And not just is it, what angle relationship is this? Angle 1 and angle 2. So again, I have 33 students in here, guys. If only 2 people are responding, it's gonna be tough because I don't like. I'm just going to assume that everyone knows how to do this. So if you're struggling, I won't know. Okay, so everyone gets this. No one's struggling. This makes perfect sense. So you guys see these are corresponding angles. Now, not only are they okay, so what we're going for here is we have all these angle rules, right? We have 4 of them. We know there's only, so if we're trying to prove P is parallel to Q, there's only 2 angles that have a relationship that are on P and Q, right? 1 isn't connected to 3. There's no relationship here. So this relationship is alternate interior. So we know if we're going to prove P is parallel to Q that we have to show those alternate interior angles are congruent. That means angle 2 has to be congruent to angle 3 for those to be parallel, right? We're building something and we're like, okay, I have to line these up. How am I going to line it up? Well, as long as angle 2 is congruent to angle 3, then these are going to be parallel, right? So we take a look here, and in one of my givens, I have angle 3 is congruent to angle 1, but I don't want angle 1. I want angle 2. So I'm going to have to first show that angle 1 is the same as angle 2. So I look at them and I say, hey, these are corresponding angles. And then even more, aren't they on parallel lines? And what did you guys find out? If I have corresponding angles on parallel lines, type into chat, what do we know about those angles? Right? If we have corresponding angles on parallel lines, type in chat, what does that mean about those 2 angles? Yes, yes. And I see some people saying they're the same, which is correct. But remember, the mathy word is congruent, okay? So I can say, hey, angle 1 is the same or congruent to angle 2. And my reason here, right, this is what we did last class. If parallel lines, now let's check. Do I have parallel lines? We sure do, don't we? So if parallel lines, I got that right there, then corresponding angles are congruent. Now take a look here. Isn't that what I said? Right? So I have parallel lines, then corresponding angles, and we said these are corresponding angles, they're congruent, right? See how my conclusion matches up with my statement. Okay. Well, we're in really good business now, right? Because I just said angle 1 is the same as angle 2. And now if we look at our map here, doesn't it look like they're all the same? Right? 1, 2, and 3 are the same. So what was my goal? My goal was to show angle 2 is congruent to angle 3. So let's write that down now because we know they're all the same. So, and you guys might recognize this from algebra. Notice how I have angle 1 equals angle 3, angle 1 equals angle 2, right? So I can say, I can replace the angle 1 with angle 2 and say angle 2 is congruent to angle 3. Now, I will take a bunch of different answers here, and I did on the midterm. The correct answer is substitution here. But if you put transitive, I would also take that. And I know some people wrote chain rule. The chain rule is transitive, right? Okay, so you get the point. We just got to make sure we start using the mathy words. Okay, so again, here substitution is what we're doing, right? We're replacing the 1 with the 2. But if you use transitive, I'm going to give it to you because you're right. It is a form of changing. There is a slight difference, but nothing that's going to really bother us. Okay, so we have substitution and transitive, or transitive, right? So you put one or the other, not both. If you put chain rule, again, you're getting there. All right, so we got what we wanted, right? See our goal? See how writing down our goal? We got this. So if 2 and 3, and you guys can tell me in chat, if 2 and 3 are congruent, then what can I say next? What has to be true? If these two angles are congruent, what has to be true? What did we write down? What are we going to do next? Right? We're trying to follow logic. So if these two angles are the same, what has to happen next? Oh my gosh, can I just say oh my gosh, did you guys do 2 capital I's for that? Because that looks like a perfect parallel line symbol. Is that what it is? I'm gonna try this out. That's beautiful. Here, I'm gonna. Or is it 2 lowercase L's? So there's 2 I's, and then here's 2 lowercase. Oh, they look the same. All right. So in Zoom, uppercase I's and lowercase L's are the exact same symbol. That's really frustrating, isn't it? Okay. So, all right. So yeah, they got to be parallel. So what I'm gonna say next is what I'm trying to prove. Oops, I was gonna put this in blue because that's what I'm trying to prove. I'm trying to prove this. So if this is true, then line P has to be parallel to line Q. Okay, P has to be parallel to line Q, and why? Because we had our goal here. If alternate interior angles are congruent, then parallel lines. Now, again, notice how we use the converse form, not the original form. Because what came first? The alternate interior angles being congruent came first. Do you guys see this? The alternate interior angles are congruent came first. Then, what did our statement said? Then it was parallel. So, order matters. Order matters. What you're concluding needs to be what you're saying. And if you're claiming something happened, you have to make sure that it happened. Okay? And that's it. Okay? So, what were the steps? What were the steps? So, step 1, we write down our given. Okay. Step 2, we set a goal and use true statements to get there. This is the hardest part, to set a goal and use true statements to get there, right? But, I mean, look at this. These are our properties. These are the rules that we learned about the game, right? So when I say use true statements to get there, we're just using our geometry rules that we've already learned, right? So it will never be something that you haven't already learned, okay? And then the last part, right, is your conclusion. Okay, there will always be these 3 steps in any proofs that we do this trimester and next trimester. You're going to start with your given. You're going to set a goal and get there by using properties that we've come up with, right? The rules of the game. So you're just using rules of the game. And then we get to our conclusion. Those are the 3 steps, okay? If we get to more complex proofs, I'll add in an extra step. But for right now, that's it. So, holy moly, I only have 5 minutes. I want to do another one really quickly. So I'm going to do one more really quickly so that you guys can get one more example. I'm going to have to go through it a little bit more quickly, but hopefully this time it will make more sense. So I'm going to set up the exact same hashtag problem. So if you're copying this down, you don't need to look at me. It's going to be even labeled the same. Okay, so I have R, S, P, and Q. And then I'm going to have the only thing different here is that my angles are going to be different. So I'm going to have 1, 3, and 2. Okay, and my givens is going to be that P is parallel to Q, and that angle 1 plus angle 2 equals 180 degrees. And we're going to prove that R is parallel to S. Okay, so this one is it's basically the same format, but it's going to be a slightly different proof. Right? We're never going to do the same proof twice because we proved it. Okay, and again, I'm short on time, so I'm really sorry that I have to go kind of quickly here, but I want to be able to get through this and respect your time. Okay? So if you have questions, you guys, we can stay after class just a little bit and ask questions. So in this case, I'm going to write down my 2 givens. So I have P is parallel to Q, and that angle 1 plus angle 2 equals 180 degrees. All right, so I have this. Okay, so now we're going to make a goal. Well, here, let's update. I said I should update this. Okay, so P is parallel to Q, so that's like that. So P and Q are parallel now. And I don't really have a way of showing this on my graph, so I'm just going to have to be really careful with how I proceed forward. Okay, because there's no way to show angles or supplementary on your graph. So now I'm going to make a goal. So I want to show R and S are going to be parallel. So I need an angle on R and I need an angle on S. Well, there's 2 angles on R, but 2 is not connected to angle 1. Do you guys see how 2, the city that it's in, is not directly connected to 1? So, but 3 and 1 are. So I'm going to say, okay, what angle relationship is this? They're both on the inside and they don't switch. So my goal here is to show if consecutive interior angles are supplementary, then lines are parallel. Okay, and I'm sorry, it's over here. So if consecutive interior angles are supplementary, then that. So what does that mean? If angle 1 plus angle 3 equal 180. This is my goal. Okay, my goal is if I can show these add up to 180, then these lines have to be parallel, right? So identify what rule am I trying to get to. So take a look at our given. Take a look at our goal. I have an equation that gets to 180, but take a look. I don't want 2. I want 3. So somehow we're going to have to connect 2 and 3 together. So I'm going to look, okay, well, is there a relationship between 2 and 3? And if I get rid of R and S, I notice like, hey, aren't 2 and 3 on the inside? And don't they alternate sides, right? So 2 and 3 would be alternate interior. So I'm going to write here, if they're alternate interior and the lines are parallel, then we know they're going to be congruent. So angle 2 is congruent to angle 3. And that is if parallel lines, and take a look, do we have parallel lines? Absolutely. Then alternate interior angles are congruent. Is that what we said? We sure did. Okay, so I'm just my logic should line up with my statements. So take a look. 2 is congruent to 3. So what can I do with 2? I can replace it. I can substitute it. So in my fourth step here, and then guys, we're gonna spill over just a little bit. So angle 1 plus angle 3 equals 180 degrees, and that is substitution. Okay, now check it out. Did we meet our goal? Yes, we did. We met our goal. We got angle 1 plus angle 3 equals 180. So once you meet your goal, we can finish up this proof. And I can say line R is parallel to line S, and my reason is what we had set out at the very beginning. If consecutive interior angles are supplementary, so let's check. Did we say that? Yep. These are consecutive interior angles, and they are supplementary. Then parallel lines. And that's what I concluded right there. So I can say that proof is done. Now, again, in your homework, you're not going to have problems this complicated, okay? That doesn't mean, if they're less complicated, that it isn't new and that sometimes new things can be frustrating. Don't be super frustrated on your own. You're not in this alone. I'm here with you. Email me. Come to my office hours. I would love to help you guys. I know 15 minutes isn't a lot, but my office hours are like 2 hours, so we can sit down and really make sense of it. Okay? So that's it for class.